Hi everyone, so for this video we're going to look at what happens with limits around vertical asymptotes. And so if you look at this graph of f here in this figure, there are vertical asymptotes at x equals 1, so right here, and at x equals 2. So we're going to look at the behavior around these asymptotes. So for part A it says, find the limit as x approaches 1, and remember this negative here means from the left side. So if I'm approaching this asymptote, x equals 1, from the left side, what's happening to this graph? Well, as I get closer and closer to the asymptote, notice that the values of y go to infinity. And so the limit as x approaches 1 from the left side is positive infinity. Part B, we're now looking at the limit as x approaches 1 from the right side. That plus sign here means from the right. So now I am not going to use this piece here because this piece is very far from where x is 1. I'm going to be focusing on this middle piece. But what I'm going to do is I'm going to see what happens as I approach 1 from the right. So if I come from the right hand side, notice as I get closer and closer to 1 that I am now also going forever to positive infinity. So the limit as x approaches 1 from the right is also infinity. And then notice in part C it says find the limit as x approaches 1. Okay, now here's the thing. It doesn't have a plus or a minus there, and so it wants the overall limit. And so if you remember from the notes, we need to look at what's happening from the left side and from the right side. And so in this case, because it's coming as it goes towards x equals 1 from the left, it's going to infinity, and it's also going to infinity from the right hand side, we want to say that the overall limit is positive infinity because they are going in the same direction. Now I know that when we did continuity that it's a little confusing because technically we talked about how when there are vertical asymptotes that the limit does not exist, and you are still correct in thinking that. However, if we're looking at behavior and we want to know what's happening to the values surrounding those asymptotes, then we're going to leave it and say that it is approaching infinity because the left and right hand sides are going towards the same values. So just wanted to make a point of that, and when you do your Math Lab homework, there is a section where it kind of distinguishes between those two things. So yes, technically the limit does not exist as x approaches 1, but since the behaviors from the left and right are going towards the same values, then we can say that it's approaching infinity. And it would be true too if it was the other way. If we were going to negative infinity, we would say the overall limit would be negative infinity. Alright, so let's look at part D. So part D says we're now going to be focusing on the asymptote of x equals 2, and for part D we're looking at what's happening as you approach it from the left hand side. So again, I'm not going to be focusing on that part of the graph. I'm going to be looking at this middle piece here because that's the piece that's closest to x equals 2. So as I approach x equals 2 from the left, notice as I get closer and closer I am going towards infinity, so positive infinity. Those are where my y values are going. I am now going to do the same thing for part E, but now it's saying that we're looking for the limit of f of x as x approaches 2 from the right hand side. So if I'm coming from the right and the closer and closer I get to x equals 2, notice the function is going down to negative infinity. And then part F, we're looking at the overall limit. So what is the limit of f of x as x approaches 2? Now in this case, it is different than what we saw in part C because they are approaching they're going in two opposite directions. So from the left, we're going positive. From the right, we're going negative. They are not approaching the same values. And so because they are not approaching the same values, this is where we would say that for the behavior of this, it definitely does not exist.